Alright. So in this question, you are given the diagram, that one there. The center is at point M where x is 2, y is 4, and it passes through the point C, which is this point here. So at C, x is -1, y is 2. And also you have got, okay, it casts the y-axis at E. So your E is there. At this point E here, x is 0 because the point E is along the y-axis. So at E, x is 0. Alright? We have got a diameter, that's CMD, and ACB is a tangent. So ACB is a tangent. That's all we are doing. Okay, then the first question says determine the equation of the circle in the form x minus a all squared plus y minus b all squared equals r squared. And we have been doing this over the past day since last week on Thursday. Okay? So, if I want to find my equation of a circle, I need to determine its center or find its center or the coordinates of the center. Then I also need to calculate the length of the radius. In this case, the length of the radius is not given, so I have to calculate it. So 4.1.1, my center is very straightforward. Okay, my center is at x equal to 2 and y equal to 4. That's straightforward. The next thing now, I need to find what is the radius of that circle. The good thing is I'm given the coordinate of the center and the coordinate of point C. CM is the radius. Okay? I don't know the coordinate of D, so I can't use D. I've used point C and point M. So, we write our equation to calculate the distance, right? So it will be r squared, which is equal to, in this case here, the r squared referring to the radius squared. Well, that's the one that I want to calculate. You can also put CM here. You can call it CM squared. Either CM or r is the same thing. So this will be x2 minus x1 squared plus y2 minus y1 squared. And I told you that this distance formula here is actually the theorem of Pythagoras. The equation of a circle itself is the theorem of Pythagoras. Okay? So we substitute my x2, if I consider the coordinates of the center as my x2 and y2, it means I'm going to have 2 minus 1 squared plus my y2 is going to be a 4 minus 2 squared. So this will give me 3 squared plus 2 squared. And then you get 9 plus 4, and that will give you 13. So my r is the square root of 13. Okay? So I found the radius using the distance formula. And the distance formula is grade 10 way. Okay? Therefore, my equation is going to be x, my y is positive, so my x is positive, x minus 2 squared plus y minus 4 all squared is equal to the radius squared. So that will be the square root of 13 all squared. Okay, you can write this as 13, or square root of 13 all squared, the same as 13.
So you do not take the same sign as y2 is 2.
No. It's your choice. You can call the center x1, y1. It's your choice. Okay. I haven't done anything which is complicated yet. There's nothing complicated. Distance formula, you calculate the radius. Yes.
So if you figure out calculating that, so the radius only is the whole number
No, this is r squared. The radius is the square root of this number. That's why it is r equal to square root of this.
isn't it r squared? So
Are you talking about here?
Yes, sir.
Yes.
So
The one, okay, the number inside the bracket, excluding that square, that's your radius.
So that's what I'm saying. So it's 13 is.
Yes. But 13 is not the radius. The radius is square root of 13. I was hoping that by now you have got this already. You see here, this is R what?
School.
So what will be the radius?
School also 13.
Square root of 13 is the radius. 13 is the radius squared.
And can you also put 13 here and then square root at the end?
Okay, actually let me write it this first, then the next step underneath it you put 13. Okay? I want you to get used to be able to determine the radius if you are given the equation. Okay? So this is the first part. Then 4.1.2, write down the coordinates of D. Right? These two words are misleading for this question. Okay? They are misleading. I would have preferred if they said determine the coordinates of D. Because you may need to do a calculation using the midpoint formula. Okay? Point M is the midpoint of CD because CD is the diameter. So I'm going to use the midpoint formula. To do that, I'm going to say, I hope you know that your distance formula can be split into two. An equation in terms of x and an equation in terms of y. So if I write here M, x, it will be x1 plus x2 all over 2, y1 plus y2 all over 2. All right? Now, these two are actually, this is a value of y at the midpoint, which I can call xm. And this is a value of y, so this is a value of x at the midpoint, that's a value of y at the midpoint. So I can call this one ym. Therefore, xm is equal to x1 plus x2. x1 and x2 are the values of x at the end point of the line segment. What I mean by that is the coordinates here and the coordinates there. That's my x1 and my what? x2. My xm are the coordinates at the center. Okay? That is, in this case here, to be the 2. So for this question here, the x value at the midpoint is given, but either x1 or x2 is not given. Okay? So I need to substitute 2 here. So I'll put 2 there. Because based on this straight line here, CD, the midpoint is given. We are not trying to calculate the midpoint. We are trying to calculate the coordinates of a point which is at the end of the line. So our xm is given. Okay, it's equal to 2. And I hope you are aware that the midpoint formula has got two cases where you will be given the coordinates of the end point. You're supposed to calculate the midpoint. That's the easiest case. This is a slightly more complex where the midpoint coordinates are given. So my x1, it is your choice now to choose whether the coordinates of the other point that's given, which is in this case C, you call that one x1 or what? x2. So I'm going to call it x1. So this x is equal to minus 1, I'll call it x1. Okay, so I'll put minus 1 here plus x2. By x2, I'm referring to the x coordinate at D. Okay, so this will be the x coordinate at D, all over 2. Then we cross multiply there. So you get 4 equal to minus 1 plus x2. Take the minus 1 to the left, your x2 is going to be positive 5. This 5 here, it is the value of x at D. Common sense tells that point D is in the first quadrant. Therefore, x at D is positive. Okay? Following that, Then we need to find y then. To find y, we can even substitute this value of x into the equation of a circle, but I'm not going to do that. I'm going to use this formula here. So I'll use this one here. Ym is equal to y1 plus y2 all over 2. My ym is the value of y at the center, which is 4. Okay? Because point M is the midpoint of CD. So I'll put 4 here. My y1 is going to be a 2. So I'll put 4 here. Then I'll put 2 plus y2 all over 2. The denominator there is a 1. Cross multiply, we get 8. Got 2 plus y2. And then you get 8 minus 2 is a 6. So y2 is equal to 6. Therefore, the coordinates of D are going to be x equal to 5 and y equal to 6. First thing, from your grade 10 and 11, you know why we use this formula? Who taught you in grade 10? Alright. This formula is called the midpoint formula. We use it to determine the coordinates of the midpoint of the line segment. Okay? Like say if you're traveling from Devon to Peterman, then halfway the distance between the two. That's called the midpoint. So we use this formula here. Now in this case, okay, in this case, let's say if I give you, okay, I don't know if this will be more complicated. But here, what we are saying is, our midpoint is the average of the x values. That is the x value at the midpoint is the average of the x values. The y value at the midpoint is the average of the y value. But now, for our question, this one now, we are given the midpoint, but one of the two endpoints is not given. So we have to do it the opposite way. That opposite way is to substitute the value at the midpoint for x. We know it. It's equivalent to x1 plus x2 over 2. So we know this. We also know one of these two, which in this case is what? X1. So we can solve for x2. Again, here, it's the same thing. We know that value is given. We know this one here. So we can get that. That's the basic idea. Okay. Any more questions? At least you are asking. Any more questions? Huh? Yeah, you see, when it comes, remember this question was from a consideration question. So there are two cases when it comes to midpoint formula. Can be given the coordinates of the endpoint, or can be given one point and the midpoint. Okay? So we need to be aware of how to do calculations on both scenarios. Okay? Let's move on. 4.1.3. Determine the equation of A being in the form y equals mx plus c. So we now know that the coordinates of D here, x is 5, y is 6. Okay? So we now need to determine the coordinates of the tangent AB. To find the equation of the tangent, as I told you that in the past few days, you need to know what is the gradient of the radius first. calculate the gradient of the radius, multiply the gradient of the radius with the gradient of the tangent, you must get -1. Then you solve for the gradient of the tangent. Then you use the coordinates of the point of contact to determine the equation. It's not difficult. Right. So let me do that. So here I'm going to use point C and point M. So I'll say M radius is going to be equal to y2 minus y1 over x2 minus x1. And that will be equal to, now it's your choice to choose whether this is the coordinates of C or M are y2 and x2 and so on. So I'm going to choose point M as my x, as my y2, so I have 4 there, minus this 2. Common sense must tell you the gradient of this radius here, because it's slanting to the right, it has to be positive. You can't get a negative gradient for a line with that orientation. It has to be positive. All over 2 minus 1. And that will give you 2 over 2 minus 1 gives you a 3. So the gradient of the radius is going to be 2 over 3. The gradient of the radius is going to be 2 divided by 3. Since the gradient of the radius is positive and it's a fraction, which is less than 1, the gradient of the tangent is going to be negative and it's going to be the reciprocal of this. So m right times m tangent give me -1. And here I'll put 2 over 3 times that. All you have to do is divide this -1 by the 2 over 3. You don't have to complicate it. So m tangent is going to be -3 over 2. You just swap these two and make the answer negative because the gradient of the radius is positive. They cannot both be positive or both be negative. No. Okay? Once you get the gradient of the tangent, it becomes a piece of cake. Grade 9 way. Okay? So, y equal to mx plus c. Then it's in this case, you have no other option. You have to use the coordinates of c because that's the only point we know along the tangent. So y is 2 there. My m is -3 over 2. My x is -1. Right? So I'll get 2 equal to +3 over 2 plus c. You take 3 over 2 to the left, you get a half. So c is going to be a half. Therefore, my equation, tangent AB is going to be y equal to, my gradient is -3 over x. The y-intercept is positive a half. And then you are done. Okay. I'm sure you can see me doing it. It's not difficult. It's not difficult at all. And as I told you, analytical geometry is one of the easiest math paper too. If you want to make your math paper too smooth sailing, you have to know what I'm doing. Right? Let's move on to the next one.
Our paper that we're going to write, how much is the analytical geometry?
Okay, we haven't decided yet because there's something that just came out. There might be a possibility that we write 2 papers. Paper 1 and paper 2.
That's one paper.
There might be a possibility of that to happen. But I'll let you know. Okay? Alright. So let's carry on. But in the end, if you write 2 papers, they will be combined. Like the final one. Alright. Let's carry on. Then 4.1.4, calculate the coordinates of E. And the coordinates of E. Now, your coordinates of E is this point here. What is the value of x there? 0. Okay? And that point is along the equation of the circle. Okay? We know the equation of our circle, so you don't have to be scared to do that question. The equation of our circle is this one here. So where there is x here, we're going to put 0. Okay? So it's x minus 2 squared plus y minus 4 equal to 13. Right? So it's x minus 2 squared plus y minus 4 all squared is equal to 13. I'm putting 13 here because I now need to calculate the value for y. Okay? So the x there, you put 0. You have to show you're working out the substitution here. Or sometimes they give a mark for it. Y minus 4 all squared equal to 13. This will give you minus 2 all squared, which is a 4, and you get y minus 4 all squared equal to 13. By now, you should know that there is no need to try and remove brackets here. So you take this 4 to the right, you get y minus 4 all squared. 13 minus 4 gives you a 9. Okay? Then you check square root on both sides. So that will be plus or minus. Okay? So this becomes y minus 4 equal to plus or minus 3. Right? When you take the minus 4 to the right, you get y equal to 4 plus or minus 3. So you end up getting two values of y. One of them is invalid. So if I take the positive 3 here, I'll get y equal to 7 or y equal to positive 1. Then the question will be, which one should we reject?
Why?
Why did they reject 1?
Because you can see it by the background.
I would say because the value of y at the center is a positive 4.
So it can be 1.
Yeah, so it can be, it can be, you can, at this point here, y cannot be less than 4. Alright, so we say here, we reject that 1 there, therefore y is equal to 7. Therefore, our coordinates of E are going to be x is 0, and y is positive 7. Don't forget, the question is saying calculate the coordinates. So in the end, we must say, therefore, at point E, x is 0, y is 7. And look at the mark allocation, means you have to do a bit of some working out. You can't just write one line in the question is 4 marks. Okay. Any question? Don't have a question, then let's carry on. Right. The next one says show that EM is parallel to AB. EM is parallel to AB. So this point here, if you join it to point M like that, that line, they are saying we need to prove that it's parallel to AB. Okay? How do you prove that two lines are parallel?
Same gradient.
Same gradient. So we know the gradient of the tangent. Okay? So all you have to do is determine the gradient of EM. So it will be M EM equal to y2 minus y1 over x2 minus x1.
But you're not trying to determine the gradient for the radius. So isn't that line the radius?
That would be better. That would be much better. Alright, so let's use that. It's much better that way because I'm gonna redo what I've done already. Yeah, but it's not the same. Okay, it's not the same. Right? It's not the same. It's not the same. I'm going to explain why. Okay, listen. You can draw many radii inside the circle, but they won't have the same gradient. Okay. Their lengths will be the same, but their gradient won't be equal. Okay? Make sure you understand that difference. Their lengths or their distances will be the same, but their gradients won't be the same of the radii of the circle. You understand what I mean by radii, right? The distances from all the lines that originate from the center to the circumference, they will have the same distance or same length, but they won't have the same gradient. Therefore, you have to calculate the gradient of each line. Okay, so this will be equal to my y2, I'm going to put it as a 4 minus the value of y at e, it's a 7. My x2 is a 2, and x1 is a 0. So I'll get minus 3 over 2. Right? I already know that the gradient of the tangent is equal to minus 3 over 2. I calculated that already. Therefore, EM is parallel to AB. The reason EM is equal to M tangent. Okay. I don't want to say because I did a calculation here. So that's not, I say the gradient of EM is minus 3 over 2, the gradient of the tangent I calculated is minus 3 over 2. Why are the two lines parallel? The gradients are equal. Okay, I prefer to write it that way. Okay? I hope you are seeing what I'm doing because in the near future that's what you're supposed to do. Alright. Any other question? Okay. Don't have a question then.